I am going to show you the difference between imperative and declarative programming using these cards. I'm going to shuffle these cards in an imperative way. You can call me the imperative guy. And I'm the cooler declarative guy. I'm going to do the exact same thing, but in a declarative way. You'll notice we'll both end up with the exact same result, except we're going to get there two very different ways. We also lied. We're not going to shuffle these cards. We're just going to take out the jokers. It's a little easier to show. Are you ready? I'm ready. So the word imperative comes from the Latin word imperare, which means to command. So think of the word emperor, right? Imperative, emperor. It's like to give a set of instructions and directives and orders, right? So it focuses a lot more on the how, individual steps to doing something, as opposed to the end result. So the following could be a set of imperative instructions. Take all the cards and lay them all down on the table. Take the first card and flip it. Is it a joker? No. Move on. Take the second card and flip it. Is it a joker? No. Move on. Take the third card. Is it a joker? Yes. Take it out. Take the fourth card. Flip it. Is it a joker? No. Move on. And finally, take the fifth one. Flip it over. Is it a joker? Yes. Take it out. And we end up with 46 and 2. A set of cards that are anything but a joker. Total coincidence. So you notice how we focused on every individual step, right? We didn't really define what the end result we wanted to be. We just focused more on doing one thing after another. And that's more or less imperative. So compare that with what the other guy has to say. Declarative guy, you're up. The only instructions I need is what we want to happen as the end result. Not the steps, not the how, but the what. So the following could be considered a set of declarative instructions. Hey, take out all the jokers and leave everything else in. Cool. I'm going to take a look at all these cards. I'm going to take out that one, take out that one. Bam, done. I am left with the end result that you declared that you wanted. So notice that we didn't focus on the how, on the steps to get there. You didn't care if I put the cards one by one on the table. You didn't care if I look at them one by one or look at them all together like the way I did, all of them in my hand. So what matters is less how to get there, but what matters more is that we got there, the actual what. So in a declarative world, we focus on the what, and in an imperative world, the other guy focuses on the how. Very nice. And again, as a reminder, we both ended up with the same result, except we got there two very different ways. Now we're going to examine how this applies to actual code. So stick around, babies. Dramatic much? Yeah. Guess what? I'm going to do the rest of the episode with the declarative guy because he's cooler, but also because I'm going to focus most of today on the benefits of the declarative programming, although as always there's caveats, which I'll get to at the end. Welcome to episode 19 of my 20-part series called 20 Things JavaScript Developers Should Know, but probably don't. This is episode 19, Imperative versus Declarative. This is the episode where I want to talk about the moment functional programming started to make sense for me. These are two different programming styles, two different really ways of thinking, and if you've only been exposed to one of them, the other one might seem confusing or even just odd. And like you saw in the intro, we can achieve the same thing with both of them, except they're two very different ways of getting there. In simple terms, imperative focuses on how. This is how you get there. We have instructions in our code that says do this, and then do this, and then do this. Declarative, it just says, hey, make this happen. I don't care how you do that. I'm not gonna prescribe individual steps for you. I just need you to achieve a certain thing. I think it will make a lot more sense when we start looking at examples, so let's just jump right into it, yo. Data manipulation. This is the example you might have seen before, but it's a good one, so I'm gonna cover this first. So let's say we have an array of, wait, I forgot, to the browser. Let's say we have an array of numbers. So const array 1, 2, 3, 4. And because I am OCD, or I have OCD, or I am OCD, I'm gonna put the spaces here. I'm also gonna do one of these. Yeah! So let's say we have an array and we want to turn every element of the array into something else. So what do you use? Let's start with our imperative approach first. Let's do a for loop. For let I equals 0. This is painful for most of us. Less than the length of the array. And then I++. Whoopsie daisy. And what do we want to do? We want to convert this into array of contrived, but doubles. Okay, doubles is an array. So let's say we want to take each element and double it. So we can then do doubles dot push. What do we want to push? Array I dot, no, that's it. Array dot, times 2. Okay, so doubles. What do doubles give us? Doubles gives us 2, 4, 6, 8. All right, so we iterated through the array and we achieved what we wanted to achieve, which is doubling every element. So this would be the imperative way, right? Because we're saying, hey, I have a variable called I, and then for every element in the array, step through it and add 1 to the I. And then once you achieve that, grab that element of the array and times 2 it, and then push it to, no. This is imperative. This is way too much control. So instead of that, what we're gonna do is I'm gonna comment that out and do it now in a declarative way. Const doubles double equals array dot map. And then what are we gonna do? Item times 2. Cool. Now doubles. Doubles is 2, 4, 6, 8. Great. So we achieved the same thing using a declarative approach, which is array.map. We do this in React too, right? So let's make this a little more interesting. Let's say we have an array of names. Sina. Oli. Whoops. And then we have, what do we want? Ruth and Dua. Ruth Bader Ginsburg and Dua Lipa. What does Ruth RGB? No, RGB is colors. RBG. What does RBG and Dua Lipa have in common? They're both attractive women. Okay. So what do we do in React? In React, we take these names, right? And let's say we do this all the time, where we take a set of data and we want to convert it into a bunch of elements. Let's say JSX elements, right? How does this happen in React? We do that, and then we do this, and then we return like a JSX element, right? We say li name. And let's change this to name. Doesn't have to do that. React is not defined. Okay, well, this tool I'm using, import React from React. There we go. So now we have React in there. Okay, so ignore the import. I like to get rid of any code that is not just a pure contributor to the concept I'm teaching. So ignore that part. But what we did was we took names and we mapped them into elements, right? Or elements mapped them to names. So this happens all the time. So you, my beautiful babies, are already writing declarative code. If you're writing React, you just may not have realized it, right? So we don't have to do it like this. We could write a for loop or a while loop or whatever imperative way of doing it, but instead it's more common to use a declarative approach in places like React. So we liked it. This is good. Next, I want to show you something else. It's my fave, because rarely anyone ever talks about this one. But it's such a good demonstration of declarative thinking, and I'm sure this is going to surprise you. It involves DOM manipulation. Yes, I know the React example had some DOM stuff in it, but I'm going to do a bunch of imperative things. I'm going to create a button, add it to the DOM, and then add an event listener, do all of this in an imperative way, and then we'll convert it. So const button equals document dot create element button dot text content equals Click me, yo. And then button, add event listener. Someone commented the other day, he was like, does this guy hate his keyboard? Why is he smashing his keyboard? I don't hate my keyboard. I love this thing. It's so simple. I know you can hate on it all you want, because I know a bunch of you good programmers out there use the mechanical keyboard, but I don't. I use the simple one. No, I don't hate it. It's just that I have a good microphone and it picks up everything. So click, I want to say like alert or something. Console log. Console.log. Clicked. Okay, so, and then we do button dot documents dot body dot append child button. Okay, so my tool's not gonna like that. I'm gonna just turn off the output and bam, a little cleaner. So this would be our imperative way of adding things to the DOM, and it's fine, right? It works. So now I'm gonna do a little separation. How you feel about this? What would be a declarative way to do this? This is declarative. This is saying, I just want a button and I want to have a click handler on it, and I want the content to be click me. To be fair, that's what that is. Button clicked. I mean, these are imperfections, but you get the point. So believe it or not, HTML is a declarative language with all the hate it gets. I know a bunch of you are going to comment and say HTML is not a programming language. If you write it in the language of the machine and you are programming, it is a programming language. So bring on the heat. There's a simplicity to this thing, right? It just describes what the UI should be, and it describes what I want to achieve. It doesn't tell me how to get there. Here's another example, a slightly more complicated, but again, there's a simplicity to what we're looking at here, because I can just look at it and know exactly the structure of this form and what's inside of it and the content. I'm not saying HTML is better than JavaScript. Don't put words in my mouth. That is not what I'm saying here. But what I'm saying is the difference between this way of adding things to the DOM and adding event listeners and things, if it can be avoided, this would be the declarative way to doing the exact same thing. And there's no coincidence that things like React and other libraries and frameworks are moving towards JSX and the more declarative approaches versus things like when we had, jQuery and things. jQuery was a lot more imperative like this. The declarative approach is really popular right now because it's easy to read and write. So I'll give you another example. I have an unordered list and we add 2 list items to it, and then we just add the UL to the body. Instead, what we can do, and this is a fairly modern way of doing things. It's been a couple of years since I looked at WebAssembly, but you could do things slightly differently, right? This should remind you of JSX, of React. It's just easier for people to describe things as the end result versus, step by step of creating an element and then adding text to it and then adding it to its parent and then adding the parent to the body. Bottom one would be the declarative approach. The top would be imperative. All right, moving on. Actually, we're going to do one more React thing, but it's slightly different than just DOM manipulation. Copy pasta. So imperative, again, it goes step by step. It says, hey, there's a button. I want to add an event listener. When I click on it, I want to add a message, a paragraph to the body, and I want to say button was clicked. Fantastic. What is a React way of doing this? The React way of doing this is function app, right? Something like this. And then we say, let's just return the elements first. Is this becoming a React tutorial? A lot of you have been asking about that. Maybe someday, you and I. Let's do a button, and then I can say, I have to type everything, so it might be a little painful for you to watch. I can say, click me, and then I can say, clicked, and P, button clicked. So now on the click equals set clicked. So let's say we have a state. We can set this to true. I think this code will work, although I'm not going to run it. Just to show you the difference between the two, we have clicked, set clicked. This is not how I normally show stuff because I'd like to just show the thing that works and use the bare minimum. But in this case, I'm mostly speaking to React babies, right? So the above is imperative, the bottom is declarative. So I'm saying the end result is exactly what I'm describing here. And when I click on it, all I want to do is have React change the state of clicked to be true. And then therefore this will become true and then this will render. So very different styles of writing the exact same end result, right? So what about CSS? Is CSS declarative or imperative? Well, let's take a look. I can have something like this. I can have a div, I can select it, and then I can set the width and the height, and I can do background color, all sorts of things using JavaScript. But the style of CSS programming, something like this, isn't describing the specifics of how you find the div or how you set the width and the height on which attribute on the element, which is style. It just says, you know what, CSS is going to abstract away all that stuff for me. So all I have to say is what I want to happen. I want the width and the height and background to change on my div. So just so you know, declarative programming isn't limited to JavaScript and the things that you see every day. It can even apply to CSS and HTML. I'm going to take this even further. How about file system, right? Operations that Node babies know what this is about. So people who write Node and want to access the file system, you can have FS, which is file system. You can grab all the files in the directory that's called directory. I can for loop it, right? So in Node, we might want to do it this way. Speaking of other languages and how we're not just limited to JavaScript, how about this? Using Bash, do you ever do ls dot directory or something like that, right? Or ls, or just do ls, right? You can see how this is actually a declarative way of telling the computer to list out all the things that are in the current directory. And so, no, it is not just JavaScript. In fact, I don't have examples here, but I think in SQL, which I am not a SQL expert by any means, but in SQL, you can also do things that are declarative versus imperative. So look that up if you're interested. Now, does that mean declarative is better? Is that the point I'm trying to get to? Not always, and I'll get to that in a minute, but first I want to talk about the parts that are better, the reasons why declarative programming is better for you and me. Number one, readability. Declarative code usually is less code. It's usually more concise, it's a little easier to understand because it abstracts away certain points. Mapping through an array, right? You saw that we can do this and we can map each element in the array to something else, right? We didn't have to write a for loop. All we have to write is the actual logic inside the for loop. We can do this with filter and reduce as well. This way, the only code we have to write is the actual logic. I think I touched on it on another video I did a few months ago. But to reduce the amount of code to the actual logic itself and not have to worry about the repetitive steps, that makes declarative programming a lot more concise in so many ways. The second reason why this is good is reusability. So what I can do is I can take the map, filter, and reduce functions and put them in their own functions. And that way, those functions now become reusable. So I can call those from different places in my code, and they become sort of utility functions that are now reusable. So reusability becomes an important piece here. Third is abstraction of complexity. So yes, a for loop isn't exactly the most complicated thing to write, but why would you write it if you don't have to, right? And it doesn't end with a for loop. A for loop is just the example I'm giving you. There are a lot of different ways that we can abstract things away that we don't have to write anymore because they're so common and the individual steps don't really change from time to time and only focus on the parts that we care about. So abstraction of complexity is number 3. Number 4, it's less prone to error. The more code you write, you are more likely to make mistakes because you and me are humans and we are not perfect and we make mistakes. So less code means less possibilities of errors. How many times have you done this? All the friggin' time. Actually, I don't write for loops as much anymore, even though that's the way I grew up. That's the way I learned how to write code. for loops are proving to be a lot more prone to typos and errors. So why not take that away? Or in the case of React, why would we manage the DOM manually instead of having React take care of it for us? Number 5, one would argue that it's easier to maintain because it reads much more like English. Now, I don't love the words map, filter, filter I don't hate, but map and reduce took a while for me to understand. And English is not my first language, but even if it is for you, it's probably not the most common word to use to achieve those certain operations, but it is a lot easier to read than this shebang, right? If you want to do a filter and then do a map and then do a reduce, this is a lot more like English, in my opinion, or spoken word rather, than this. This is just programming, right? This is just a bunch of mumbo jumbo that you have to know what a for loop is. You have to know what a let I equals 0 means. I would say maintainability and readability are a big plus. And number 6, this is a bit controversial, but performance and parallelization specifically become more possible when you use declarative programming. What do I mean by that? When you write declarative code, you are allowing the underlying system to optimize the execution of that code. I know that sounds like a lot of programming terms, but you can think of it as React batching updates to the DOM the way that React thinks are most optimal and most performant. So if you use React for updating the DOM, you're giving React the opportunity to use all of its algorithm, all of the work that has gone into making React performant, and you don't have to do any of that. In fact, chances are React engineers, are better at doing that than I am. So by abstracting those things away and giving it to the React library to take care of it for me, I am allowing the system to do this in a more performant way, maybe parallelize certain things. I think I touched on SQL, and databases actually have different query plans where they can optimize the query, and if you do it in a declarative way, they can take advantage of those benefits. So yeah, you can imagine if you leave the implementation detail to a centralized system such as your framework or your library, or even honestly a utility that you wrote yourself, they can focus on the performance optimization and you can focus on the business logic and all the fun stuff. So now, what's the caveat? Is declarative always better? Like I said in the beginning, not always. Declarative programming isn't universally better. Why? Well, we said declarative programming hides the how, right? The individual steps to achieving your goal. So in some cases, it can hide too much of the how. For example, let's go back to our original, for loop. The for loop is something that you write usually going like this, right? From 0 to the length of the array. We go through the array sequentially from first element to the last element. Now, what if we want to do the opposite? What if we want to do backwards, right? We can change a for loop like this. So we can start from the length of the array, length -1, and then we can come back minus instead of plus. This is just not possible with array.map. Array.map always goes from first to last. And so if you want this level of control, you probably want to use the imperative approach because you care too much about the individual steps. Now, couldn't I just use a map and then reverse it? Yes, you could. And the whole point is that, yes, you can achieve the same thing in different ways. So if that level of control is what you're looking for, then imperative programming might be better for you. Also, for people who are doing data structures and algorithms, you notice that in a lot of algorithms, you do need that control. In a lot of scenarios, there isn't really a utility that can do the thing that you want to do if you're writing a really specific algorithm, right? So with algorithms are very much imperative and you go through each step one by one. So I hope the benefits of declarative programming are clear now and that you know that it's not mutually exclusive with imperative. In fact, in big applications, you can mix and match, and you are likely going to mix and match. But I hope you also know that declarative programming is not always better, but in a lot of cases in modern JavaScript, the declarative way of thinking is becoming a lot more like a standard because it does achieve so much of what we want with less code. And that's it. That is episode 19. It was a little shorter. I wrote a little less code. And yeah, this has been episode 19 of the 20-part series I'm calling 20 Things JavaScript Developers Should Know But Probably Don't. The next and last episode of the series will be I can't tell you. You'll just have to wait and see. I do know what it is though, and it's gonna be good. One of your most common requests, so I'm looking forward to doing that, and I'm hoping that I can do that fairly soon. And with that, I'm gonna bounce. Thank you for tuning in. See you on Instagram and see you on the other side. Actually, let's get that other imperative guy in here for our outro.